Bismillah ar-Rahman ar-Rahim. This is a paper, October 24, 41 variant, complete mechanics paper. We are going to start. Question number one, we have two particles, mass 1.8 kilogram, 1.2 kilogram, are connected, past a pulley and vertically hang, and systems released from rest. Best technique, write data, use zero, okay, and make diagram. Magnitude of acceleration is our task to find, and find tension. So tension is a task as well. So have a look, students. So I'm going to, okay, the particle is not mentioned what the names are. So so I can label any here, A, B, and the particle of mass A is 1.8 into 10. I got 18 newtons. And B is I have taken into 10. This is 12 newtons. And tension towards pulley for sure. Okay, now, so let's talk about A particle, common sense. This is heavy, okay, mass, and this is a lighter. So naturally, this will move downwards, so motion downwards. And this motion upwards. And best technique formula, net force is equals to MA. How many forces acting on a particle? Two forces acting. One downwards, one upwards. But 18 and T. But question come, which is some students start wrongly. They start T minus 18, wrong. Because motion is downward, so this 18 is a bigger force as compared to tension. So I'm writing 18 minus tension is equals to MA, which is 1.8A. Now let's same root formula apply for B, but make sure B is going upward. This arrow mentions, so tension is more and 12 is lesser. So I'm writing T minus 12 is equals to 1.2A. And I believe point is very clear. Tension cancel. I got a 6 newtons. If you add this, I got a 3. 3 will go down, and I got acceleration 2 meter per second square. And I will put this value in any one equation. I'm using the lower equation to plug in T minus 12, 1.2 times 2. And this is becoming with us 14.4 newtons. Sorry, 14.4, yeah. So 14.4 newtons. So I hope so. The point is very clear and question is clear. Let's go for question number 2. Question number 2 we have here, the particle of mass 7.5. Best technique, read and write. 7.5 kg and start from rest. So velocity at A is for sure equal to 0. Okay, and slides down, incline, it slides down, and the B is 112.5 meters vertically up. Okay, and the plane is smooth. The first part, there's no friction at all. Energy method to find speed at B. So here very important part, because the whole paragraph it did not mention what is applied force. Not engine is working, not applied force. So applied force is 0. When applied force 0, work done by applied force is confirmed 0. And part number A, friction force 0. So that is why I will take small the friction force 0. So work done by friction force is 0 as well. And special formula we use, these kind of questions are magic formula I call normally work done by applied force, work done by frictional force, kinetic energy plus potential energy at end, because particle is coming downwards and end point is B. So B minus kinetic energy plus potential energy starting point A. So this formula call I name as a magic formula. But as you know, this both values are 0. So I will bring any one on left hand side. So I can write it here, kinetic energy plus potential energy at a B is equals to kinetic energy plus energy at a. I repeat my words. Is a negative sign. If I bring on the left hand side, it becomes positive. So it means I will get it this form. So now, so you can see, because our task is to find speed at B. So I'm going to plug in here half m V square at a B. But because height is 0, so because potential energy is mass gravity into height, as height at B is 0, so this is confirmed 0. So what is kinetic energy at A? Because speed is 0, formula is a half mv square, because speed is 0, so this is 0. So I'm writing here 0. And potential energy is m, g, and h for the A particle. Okay, this is so mass cancel from both sides. I got a half time to velocity of v square. Gravity is 10 and height is very clear 12.5. Now this 2 will multiply there. So I will get simply, and here I'm writing now. And wait a minute, just drag slightly here. So what I can say, velocity b square equal to 2 times to 10 into 12.5. And if I check in calculator, so 12.5 into 10 into 2, and I got 250. And velocity, or this one, 250, and take a root of this, and I got 5 root 10 of velocity of b is 15.8 meter per second. I believe the point is very clear. Okay, he did not ask for exact is 5 root 10, but if you write VSF is a 15.8. I hope so. The point is very clear. So now next part is, instead the plane is rough. Now first he says smooth, but now rough. So I will write again this formula. You can see this formula again. I'm copying and I'm pasting here. Okay. So this is formula available. Now, as you know, because let me read a statement first for you. Is a rough, so friction is not equal to 0. And particle reach at speed, air velocity is 8. All right, so plane distance is at 25 meters here. All right. And he's asking the frictional force currently working for capital F. Okay, find capital F. Again, because you know applied force is no throughout the motion, so this is 0. I'm going to write here 0. And what is the formula of the work done by a friction force? Small f into d. And this friction force is capital F mentioned here. And distance, I know 25 along the plane 25. This is a 25-meter distance from here till here. So this is a very clear. Now kinetic energy at a B, he said that. So I have m is 7.5, have mv square. But potential energy at B is 0, logic, because on a ground level. And kinetic energy on A is again 0 because starting from rest. Negative into positive give you negative, and potential energy formula mgh, mg is 10, h is 12.5. Is it just a matter of, that is why I call its name as a magic formula. Reason, simple, plug in the values and get the answer. And I'm going to finalize it simply typing in calculator, and my answer is left hand side negative 697.5 and negative 25 f. 25 will go down, and when I divide, I get a 27.9. So Alhamdulillah Rabbil Alameen. I believe you people understanding. This question is done. So question number 2 is over. Let's go for next question. Question number 3 we have. We can see the question, coplanar forces, 52, 39, and P newtons. A point of direction so shown in diagram. System in equilibrium. Equilibrium means sigma, like all x net force is 0 y. It means I can say rightward forces, leftward forces are equals to each other. Upward forces, downward forces are equals to each other. So first of all, this component I will make it is so clear. This force I'm going to make one parallel to x-axis and one parallel to y-axis, because theta here, so I will write theta here. And this is a P cos theta. Basically, where angle given, that is cos component, and where angle not given, that is always sine component. Okay, it has a no component break because 39 acting on x-axis and along y-axis, even no component breaking. So I can resolve for those only which has some angle. Now, students, I can make it easily because equilibrium, so left hand force and right hand force are equals to each other. And I got a P cos theta is equals to 39. Same way, upward force equal downward force. So I can say P sine theta is equals to 52. And students, we have two ways to solve, but easy way. Sine by cos basically tan theta. So I can say here, I call the numbers one equation divided by two equation. So I'm keeping this equation. Then this equation, look at I'm copying, just showing you this paste here. And second equation, I'm copying and I'm going to paste down. Basically, what I'm doing, I'm dividing them. Okay, basically, so I am erasing the middle equal sign and writing a single one and dividing. Dividing means this up, this down. Sorry. Yeah, sign up, cos down. And same with this up and this down. PP cancel and sine by cos will give us tan theta. And tan theta is becomes 52 over 39. Take a tan inverse of this. And when I take a tan inverse, students, so tan inverse of 52 divided by 39. So we are getting theta answer is 53.130102. You can may ask me why is write so long answer? Because I want to use it here for long answer. But when we write angle, we write one decimal place. And this we don't need, which I don't need, bigger than 4. And no, I will not add. So answer is 53.1 degree. But how to find the P force? So this angle, either I plug in it here or here. I'm going to put in 1. Put in 1. So P cos theta, and theta, I'm writing a long answer for more accuracy. And when it goes down, if you use 53.1, maybe you will lose accuracy. So that is why for increase the accuracy level, we have to type a long right. So 39 divided by cos of the angle, and I'm getting 65. You see, I get a 65 newtons. So due to that accuracy level, I got very close to accurate. I hope so. The concept is very easy. Question number 4 we have. Question number 4. Bus travels between two stations, two stops A, B. The bus starts from rest A and accelerate constant rate of A acceleration. So it means if I make it this diagram, so you can understand from here, this acceleration is A. Acceleration is A. All right, reaches speed of 16. So what reach speed here is maximum speed is 16. And time is how much? I don't know. I given this time as a T1 from here till here. Fine. So then it travels at a constant speed. It's moving constant speed. Okay. How much time? We don't know about that. He said that after, before it decelerating, and all right, decelerating 0.75. This one, decelerating and compress at B. Okay, and what is the deceleration here? 0.75, but I am writing deceleration 0.75, or I write acceleration equal to negative 0.75 A. You may ask, so why you plug in negative sign? Because the deceleration means negative. That is why I kept negative sign here. Okay, and in the total time journey is 240. So this is 240. And this, I bring it down and like this. And okay, this is T2 gap. Hold on, T2. This from here till this time is T2 gap. So this diagram for 1 mark, I think up till here clear. What is asking for expression in terms of A for the length of time the bus is traveling constant speed. So we have to look for this time. How to get this time? Total time is 240. And this T1, T2, if I get a T1 and T2, if I add them and subtract from 240, I will get this time. And I believe this part is clear. And this I count as a 3. Okay, so have a look now, students. So what is acceleration formula? You know it very well. Velocity over time. So 16 over t1. So t1 goes there, acceleration come down. So I got a t1 equal to 16 over a. First part done. Let's talk about this one. What is the deceleration criteria? So you know y2 minus y1. Hold on. Some student getting problem. I just tell you what is here. Time is okay. For example, I just tell you what is the end velocity is 0. What is end velocity 16? So 0 minus 16 will give us negative 16. This is the main problem. Some student never understand this part. So I repeat my words because particles traveling and stop here. So last velocity minus initial velocity. Here we have a, okay, if you're not comfortable, you can use this formula. V equal to U plus 80. So what is a V? 0. What is U? 16. And this is another way to understand. Okay. Or I am using this is a negative 16. How come? Because 0 minus 16, that is reason behind. Okay. And I'm using the time, and there is a T2. So T2 goes there and resolution comes this side. So T2 becomes 16, negative 16 over D. And D value is this one which I'm writing now. And I'm writing with a negative sign. So T2 is equals to negative 16 over negative 0.75 times 2A. If I type this in calculator, students, so let me check 16 over 0.75, it turns to be 64 over 3. So 64 over 3, and I am going to write finally here T2 is equals to 64 over 3, and this A is already in denominator. But he is asking us not this only, he is asking us find out the time, find out the time for in terms of A, the length for the constant. It means planning to find T3. So T3, how to find? From 240, subtract T1 plus T2. I believe you got a point. And 240 minus T1 is 16 over A and plus 64 over 3A. And I believe the concept is very clear. And this he was asking us. So we have done it, and we can take the LCM even to make it easy. And 240 as it is, and 3A is LCM. So I'm writing 3A, and wait a minute. So 16 into 348. 16 to 348. This is a 3A. And 1 minute, please. Let me check it. Into 3 into 348 and plus 64. I got 112. And wait a minute. For example, okay, let me show the working, what I'm going to do. So actually, I take an LCM 3A. This is 64 as it is. How to make it 3A into 3 down into 3 up. And 16 into 3 become 48. And finally, I got 240 minus 48 plus 64. I got 112 divided by 3. I got a 112 over 3A. This is my final answer. If I stop here, even correct answer. So no problem at all. Now, students, we have to go for next part. Distance of A to B is 3000. It means the whole trapezium area is 3000. And have a look now. Area of trapezium is half into H into A plus B. Basically, this is a 3000 area. I'm writing here 3000 and half. And what is the H? H is a, okay, maybe some student have some maybe problem. I'm just drawing this diagram. This is A, this is a B, and the gap between them is called H. H is 16. So I'm writing here 16, and the first value of this top line is this much. So I'm copying here 240 minus 112 over 3A. And this is a value, I got it for A. And what is a B is a total gap, and there's a 240. So I'm writing here 240 add. Okay. Now this is a 6. This A time, it goes down like this. 240, I got a 480. Okay. Now this is a 3,000. 3,000 divided by 8, and I got it 375 equal to 480 is equals minus 112 over 3a. So 112 out of 480, subtract this one, 105. And 105 into 3 divided by 112, we got acceleration 64 or 44 over 16. And that was, he was asking us, we got, alhamdulillah, okay, answer of this one. So this is an answer for acceleration. Wait a minute, I think I typed wrongly, opposite I wrote. It should be 16 over 45. 16 over 45. Let me check finally. 1 minute, please. Yeah, 60 over 45. This is done because this A will go there, it will come down. So 16 over 45. The concept is very clear, and the question is over. Question number 5, we have a particle A is projected vertically upwards from O with speed of 80. Okay, another 1 second later, second particle B with the same mass, it means both masses are same, is projected vertically upwards from O. It means they're thrown upwards from same position with a speed now 100, first 80 and now 100. At a time t second after the first particle is thrown or projected, the two particles collide and coalesce to form a particle C. So this part is clear. This part is clear, and show we have to prove it. The time is this much. So when they collide, collision means they have a same height. So let's see. I give idea. Let's say one particle is thrown upwards and speed of 80. The second particle is thrown upwards, same mass, speed of 100. And though they are not like this, okay, I just give an idea. So this particle is like that. So they are traveling in a same line, actually. Just a temporary, I show you the concept. So what situation going upwards, naturally gravity -10 for both particles. Okay. And at that particular point, they have same height. Same height because they collide according to situation. So what is method to solve? So we will make a plan. This is a particle A and this is a particle B. So let's make a plan for particle A. Particle A, what formula we can use? Let's say the time taken for this particle is t second, and other takes 1 second less, because he said that 1 second after. So that is why I kept t -1. And apply formula, data is enough. So S is equal to ut plus half gt square. And I'm writing here S by A particle is U is this one, and capital T plus half times 2 -10 nt square. And it turns to be S particle A, this one, ADT -5 t square. So equation 1 done. So this is a one situation. Let's talk about B. Data is very clear, 100 times and G is given. So I'm just applying same formula and values are very clear. So S is equal to UT plus half GT square. So I'm writing here distance traveled by the B particle, and U is 100t, but T is capital T -1. Half times to -10, and here T -1 to power 2. So this is 100t -100 and -5, and here I use squaring identity. And squaring identity means square of the first term, -2 into first term into second term plus second term square. Distance by B is 100t minus 100 is 5 multiplied inside 5t square minus minus plus 5 2s are 10t and minus 5. So I got both. Now, according situation, as we know, distance by A and distance by B, I mean, both heights are equals to each other. So I'm writing 80t minus 5t to power 2 equals to negative 5t square. I copied from here. And this 100t and 10 become 110t. And 100 and this 5 becomes negative 105. This cancel out. And I will bring 105 on this side and this on the other end. And I get it what here, student? Out of 180 gone 30 and 105. And if I divide 105 divided by 30, I get a 3.5, and that was our task to prove. So I hope so. This part is very clear. So this part we've done it, and now let's go for next plan. And next plan is find the height above the O which the particle collide. So we need to find the height. So how to find the height, the collide? So I have two options. Either I plug in this and this, or plug in this value in this equation. So I think upper equation is better. So height gained by the okay. So I have 80t minus 5t square. 80t minus 5t square. So 3.5 here and 3.5 here. So when I multiplied 80 times 2, 3.5 minus 5 times 2, 3.5 square. And I'm getting to an 18.75 meters. So this is the height of the particle from O. So done it. Alhamdulillah Rabbil Alameen. This is over. Okay. Let's go for the next part. Next part, we find the time for A being projected until C returns to O. Until C. Now, C is what we don't have a C. Actually, C we have at coalesce. When A, B will become one object. So find the time for the A being projected when A is thrown from beginning until C or return to O. So now I'm doing the situation. So you know this is when the both particles are traveling, and they you know, first of all you can say that so they are traveling, and time to being projected until C return to O. So first of all, I need to find, let me give a plan. This is a just before. You can say that, okay, I just show you the diagram is better to understand. This is a particle A and the particle B, and particle A is this one just before collision. After collision, they will behave like a together coalesce. And this I count as a C. Interesting part, this is just before collision, and this just after collision. Okay, and you know what happens, students? After, because just before collision and after colliding, this will go slightly up, stop on a peak, and then fall down and reach on the ground. So time taken for A being projected until C return to O. So we need to find this time. We need to find this time. And this time, just before collision, we have it. So this is not a hard thing to do it. So this time, just before hitting the, okay, and this time and this time. So 3 times I have to add to get the answer. But thing is that first, students, I have to go for the collide. Okay, so let's talk about. But problem is only one we are facing. Do we have this speeds? No, we don't have this speed, and this speed is my question. Okay, this speed, do you have? No, not at all. So let's try to do it. And we have 2 equations already. This equation, I will use this data I have available. and I can use this data and get the V, okay? And T, we know it. T is 3.5, we know it. So let's talk about the A. U is 80. Time to reach that but just before hitting is 3.5, and gravity going upwards -10. Last velocity just before hitting I want to find. So V is equal to U plus 80. V is the task, 80, and gravity is -10, and time is 3.5. So this is a velocity of the A particle just before hitting, okay? So 80 plus -10 times 3.5, it gives us 45 meter per second. So this is a velocity, okay? We can say that this velocity of this particle, okay? All right, now same manner, I will go for B particle, and U is 100, we know it already, and time is 3.5, and gravity is, you know, -10, and last velocity is task to find. Again, V equal to U plus 80 or GT. So last velocity U is 100 and gravity is -10, and this 3.5. There's a 35 and I got it 65. I got here, yes, I got a, just let me check. Yes, it is coming with us 45, and let me recheck. 10 times 2, 3 point. This 3.5 or, yeah, 3.5. 3.5. So I get it here 65. Okay. 1 minute. This check again. This is I have to find. Make sure this T minus 1, not T. Sorry for that. So this is a not T. This T minus 1. When T minus 1, so this becomes 2.5. So this is a y I have to plug in here 2.5, and that is why velocity of the B particle becomes 75 meter per second. So it means velocity of just before hitting this one. So now I'm applying law of conservation of momentum. M1 U1 plus M2 U2 is equals to M1 plus M2 times 2V. Because, you know, both masses are same, I will deal M1 equal to M2 equal to M. So every mass I will take as a M. So M times 2 U1, velocity of the A is 45. So 45 meters. And this is again M, and this 75. Okay. And equals to M plus M, this becomes, you can say M plus M becomes 2M. This is okay. Now 2mv, this is M, it is 120M. Mass cancel, and I got velocity just after hitting is becoming 60 meter per second. So this is the velocity after this velocity, I got it. Okay. Now, students, very interesting. Let's discuss this situation now. So this velocity is 60, and now this particle will go up, stop on the peak, last velocity is 0. But what is this velocity at this moment? 60. Last velocity is 0, and gravity is naturally -10. It will stop somewhere. So let's make a plan. I'll just say that free fall upwards motion for C particle. Okay, so U is 60 now. This V becomes 60. Okay, and what we have, gravity is -10. Last velocity is 0. Okay, and I will find two things. I will find distance traveled by this, and I will find time as well. Okay, I'll count the time 1. So let's go for it. V is equal to U plus a GT, and last velocity is 0. This is 60, and gravity -10, and T1. So T1 becomes 6 seconds. It means this is a time to reach after collision become coalesced, and how much time to reach at the top is a 6 seconds. Though before collision we have time 3.5 seconds. We have already. Okay, student, after this, what is the plan? It will reach on a peak, and then it will fall down to reach the ground. But problem is that this height, I have it. Where this height? You can see this at 2.218.75. But do we have this height? No, I will find it height. And that is why I'm finding it height. So let's try to do it. Have a look. So that is why I wrote S. So I'm finding S now. And formula, S is equals to UT plus half, or wait a minute, let me check. I think I can use the other formula is better. Okay, and that is a 2AS is equal to V squared minus U squared. Going upward, -10, S is a task, last velocity is 0, this 62 power 2. And if I check it, 62 power 2 divided by 20, and we get 180. So 180, we got it. 180 meters, I got it. So it means while going upward, we got this velocity distance. Okay, now I plan that if the C part, like if they are the coalesce the both particles together, C is while falling downwards. When falling downwards to reach the ground, okay, ground. So starting velocity is 0, gravity is coming down is +10, and time is our task. But problem is that how much this distance, and distance we can find it, and which I'm going to find here. Get ready for that and have a look. Now I'm saying free fall down for C particle, and data is very clear. Use 0, and time 2 is a task. Okay, and gravity is coming down positive. But important part, what is S? S is, for your knowledge, sake of understanding, 180. This is a 180, and this is, I just got it here, 218.75. 218.75. So 218.75 plus 180. So this is turned to be 218.75. The add, I got 398.75 meters. This distance, it has to fall. Okay, and let's try to find time. So time becomes what, students? So S is equal to UT plus half GT square. Distance is 398.75 is 0 here because this starting 0. I'm not wasting time, and half into 10 into T square. So this 5 will divide and then I take a root. So I mean like this, 398.75 by 5. So when I divide by 5 and take a root of this, I got a time 8.39, 8.93 seconds. Is a time 2 actually. So time 2, I got it. And now what is the question he was asking? Start from A, from projectiles to beginning, return to O. And if you look at carefully, starting from here, so first it takes time, that is a 3.5. So after 3.5, this time I got it. I got it here. Wait a minute. This time I have it or not? Wait a minute. This time I just got it here 6 seconds. So if I check it carefully, the times are what? So total time is what? 3.5 plus 6 and plus 8.93. And if I check it, so my answer turns to be final answer, if I added 3.5 plus 8. Let me check again, 8.93 plus 6 plus 3.5. The answer final is coming 18.43 seconds. And I hope so. The concept is very clear. This was a little tricky question, but I hope so you got idea. And the question is completely over. Rounding 18.4 seconds. Question number next is 6 number. The particle of mass 1.2 is placed on a rough mass 1.2. So best idea, read and write. So I'm writing here, mass is 1.2 kg, which is inclined theta degree horizontal and sine theta given here. Check it is rough or smooth. Yeah, we can see this coefficient is rough. So it means if I have a sine theta, I need cos theta. And how to find cos theta? Cos square theta is equal to 1 minus sine square theta. If I take a root of the both sides, students, so this power will to eliminate, and I get a root of that. So when I plug in the values, 1 minus 7 over 25 power 2 of root. This will give me 24 over 25. So this is done. So now I have the important data. He said kept in equilibrium. So it means acceleration is confirmed 0. Okay. And he said further coefficient friction is given 0.15. So mu is given 0.15. And now least possible value. We have two options: least, if it is about to, because he said equilibrium is about to move up, if force is acting such a way is about to move up, friction backward, that is called maximum force. But if it is a least, so it means the force is not enough. So least force, least, and that is about to move not up, about to move down, and friction will be upwards. I think you got a point. So let me finalize it. So diagram, I'm going to finalize it, but before I start, so this very interesting. But first of all, this mass is mass multiplied by 10. If at 10 I multiply, I got 10 in 12. Okay, and what is this formula? Actually, mg sine theta, basic formula. So 1.2 into 10 into sine theta, which is 7 over 25. So I'm going to write it now here, and you can see this is a 1.2 into 10 into 7 over 25. This is mg sine theta. Okay, and applied force is, okay, now this is okay, clear. Is a weight is acting downwards, and that weight is 12 newtons. And this is up and down, you know it very well, R. So this is R normal reaction, and this is 12, actually 1 mg cos theta. M is 1.2 into 10 into cos theta, which is 24 over 25 I got from here. Okay, this is clear. Now, last final thing, when this P is pushing here, okay. So, for example, this is a theta, okay. Do you know, student, when two lines are parallel to each other, line cuts up. This is a theta, this understood theta. So it means this theta, this is a theta as well. So I'm writing this theta here. Okay, when this theta acting here, so this force has a two component. Make sure always rule is what? One acting parallel to surface. Okay, a little bit hard to understand. They look at the surface and this parallel to each other. Okay, and one acting perpendicular. It means, look at, see here, this is making how much angle making here? 90 degree. This is a 90 degree. So I believe this part is very clear, and this is a okay, interesting part. One more interesting part: when two lines are parallel to each other, a line cut this way. If this is a theta, this is also theta. So you see this parallel line and this parallel line. So if you look at carefully, if I show you this parallel line, this parallel, and this line cut, if this theta, this is also theta. So I believe you people understanding. Here I'm writing theta, and here I am erasing it now. Is clear. Okay. Now this theta, and obviously this is a theta and force is a P. So this would be P cos theta. And this is which acting downwards. I will bring it down, P sine theta. I think the point is very clear. And now, students, I'm going to finalize the day. And one thing is missing, because about to move up, I will the word about, no, so least force. Whenever least force, it is a about to move down, make sure, okay? Least force about to move down, about to move. Then friction will be naturally opposite sign, it means upwards. Now, students, we have done all forces. This was hard task. But anyway, now how to do it? First, we talk forces perpendicular to surface. So perpendicular to surface forces I want to take. Perpendicular means this surface, I have it, students. So this upward and this downwards and this downwards. Okay, perpendicular. My question again, how much angle R making? 90 degree. How much this angle? 90 degree. How much this angle? Force P cosine make it 90 degree. So it is all 90 degree. So I can say R is equals to this plus this. So I think this part is clear. Perpendicular to surface. So R is equals to P sine theta plus 1.2 times to 10 into 24 over 25. So this is a done. Okay, now I'm plugging the values. Values are very clear. Sine theta value is this. So I'm writing here 7p over 25. And this I'm typing in calculator. So 12 times to 24 over 25, which is coming with me 288 over 25. In this way, the question becomes a bit easier. Okay, so this is okay. And now, okay, this is, let me check once again. Yeah, correct. Okay, let's move on this one. This next one. So what is a friction force? Friction force is F is equal to mu r. And what is a mu? 0.15. So I'm finding friction as well. So 0.15 times 7p over 25 plus 288 over 25. In this way, question becomes easy. So when I multiply with that, so 7 over 25 times 2.15, I'm getting 21 over 500p. And when I multiply 288 divided by 25 into 0.15, I'm getting 216 over 125. So this is a friction force done. Now let's talk about, because system in equilibrium, he said according situation, these two forces acting upward, this force acting downward. So this plus this equal to that. Or I can say net force equal to MA, this plus this minus this equal to 0. Or say these two components acting upward, is downward, they are balanced. So I'm writing now P cos theta plus F. So now I'm talking about along the surface, along the surface. So what I was saying, P cos theta plus friction force equals to this component, okay, to 1.2 times to 10 into 7 over 25. So this whole value I'm bringing down here. So P cos theta plus 21 over 500p plus 216 over 125 is equals to, this is a 12 into 7 divided by 25. I get 84 over 25. Now this will go on the other end, and from here I can take P common, but cos theta has some special value, and that is 24 over 25. So from here I can take P common out. When I take P common out, inside the bracket 24 over 25 plus 21 over 500 is equals to 84 over 25 minus 216 over 125. Now this will divide the fraction and I will get my answer. And let me check it. Okay, I'm just saving the time. Minus 216 over 125. I get it here. In decimal 1.632. And when this divides down, what this answer turned to be 24 divided by 25 plus 21 over 500. And this turned to be 1.002. And finally, I get the answer 1.632 divided by my previous answer. And answers turned to be 1.6287 after rounding 1.63 newtons. I hope the idea is very clear. Question number, next we have 7 number, and the mass is 1200 kilograms, okay? When car is traveling speed of V, okay, clear. There's resistive force. It means friction force, resistive force or friction force. So let me write it here. Friction force is kV throughout the question. Maximum power is this kilowatt. I will multiply with 1000, so 92160 watts. Okay, So car travels horizontal straight track. Greatest possible constant speed is 48. When you say the maximum speed or constant speed is a 48, 100% confirm acceleration is zero. Because when speed is constant, no change speed, so acceleration is zero. We have to show this one. So what is the basic formula? Net force is equals to ma. So when any object is like this example, this applied force, backward is a friction force. So we write capital F minus small f is equals to ma. And basically formula of the force is power is equal to F into V. And if I want to make a F subject, so V will go down. So I'm writing here P by V minus friction equals to ma. Power is 92160. Over speed is 48. Friction force is kV, but K is unknown. V is 48 and equals to 0 because acceleration is 0. So I bring 92160 over 48 is equals to, this will go on the other end, K times 248. If I divide 48, and it will come with us. If we check it, so answer turned to be 40. Proved. So Alhamdulillah Rabbil Alameen, this is done. And next part, he said at instant the speed is 45, not change, plan change. Previously the speed was 48 and that was a maximum. And now he said change, find greatest possible acceleration. So we need to find acceleration. So basic formula remains same, students. So I will use the same formula. Power by V minus friction force is equals to ma. Power is 92160. Speed is 45. Friction is kV. K is kV. kV. But K is 40 and V, I just got it here, 45. So I'm writing here 40 times 2, 45. And mass is, I think so, 1200. And acceleration is my task. Simple, type this in calculator, divide by 1200, and I will get my answer. 92160 divided by 45 and minus 40 times 245. I'm getting 248 equals to 1200A. And if I divide by that, I get acceleration comes 31 over 150, or in decimals, it's turned to be 0.207 meter per second squared. So I believe the point is very clear. Let's go for next part. The car is now traveling at a constant speed. Again, he says constant speed. So constant speed means acceleration 0. And angle is given. So it means angle is given sine inverse of 0.15. If I bring sine inverse on this end, so sine theta is equals to 0.15. Okay, find possible, greatest possible of the speed of the car up the hill. Okay, so how to find it? Make sure, students, so this is speed. This time, you know it very well. We have a situation, what? Have a look. And okay, and this is a theta. And let's say a car is traveling. Okay, just example, I make it. This is applied force, and actually P by V. Applied force or P by V, same thing. Or I just write here, first of all, applied force. So friction force is downwards and weight is mg sine theta. So because motion is upwards, all of you familiar. So what is the basic formula now? Again, same, net force is equals to ma. Because motion upwards is a bigger, these are both smaller. So capital F minus friction minus mg sine theta is equals to ma. And here power by V minus friction is a kV. Okay, minus mg sine theta is equals to ma. Power, we have it, how much? 92160. 92160. And speed, I need to find. K is 40, V, M is 1, 2. Here I'm writing all together. Mass is this sine theta is 0.1. So mass is what? 1, 2, mass 1, 2, 1, 2, 0, 0. 1, 2, 0, 0, 10 into 0.15. It comes from here. And if I check it, so 1200, one more zero into 0.15, I'm getting 1800. Mass is 1200 into, sorry, this is acceleration 0 because constant speed. Sorry, yeah, constant speed. Will do what? Multiply into V. So I got a 92160, and V times 2V will give us V squared. And 1800V equal to 0. I'm writing in order. First, I'm writing 40V squared plus 1800 and negative 92160. Now, what is A value? A value is, okay, I'm writing directly. So that is a familiar. You are negative 1800. Minimum this formula you have to show. B squared minus 4A into C, which is a negative 92160, and divided by 2A. And when you apply the formula, I get a two answers. Let me check. Yes, this one I'm getting here. First answer, I'm getting 30.5. Second, I'm getting negative 75.5. And this I'm ignoring. Okay, this I take it. So my answer is this much. These are negative velocity is coming back to observer, but here he is going away from observer. I hope so. The concept is very clear. Let's go for next question. Question number 8, we have particle P moves in a straight line, passes through O, and its velocity is 4.2. So first of all, make a rough diagram. O is starting and going this way. When its starting time was 0, velocity was 4.2. After the passes through O, acceleration is this. So let's write acceleration. So find distance, speed, travel between the point when it's rest. Rest, what does rest means? When is a velocity is 100% to 0. Okay, stop somewhere. But do we have the velocity? Not at all. Actually, let me tell you one thing. Displacement, if you differentiate displacement, we get a velocity. If we differentiate velocity, we get an acceleration. Differentiate and differentiate. But if I want to come down, it's called integration. If you want to come velocity to displacement, I will again integrate. So currently, I am on the level of acceleration. If I want to come down, I will integrate. So let's start integrating both sides. I will get velocity automatically and 0.6 t negative 2.7 dt. Increase the power by 1. So I got 2 by 2. How 2? Because no power means 1. And 2.7 t and plus c. I will plug in this data, which is a very important to plug in. I say put times 0 v 4.2. So 4.2 is 0 minus 0 plus c. So c becomes 4.2. And final equation I get, if I divide them, I get a 0.3 t squared negative 2.7 t and plus 4.2. And velocity expression, I got it. But now I will plug in velocity 0 because for the rest or for the stops, I must plug in velocity 0. So 0.3 t squared negative 2.7 t plus 4.2 is equal to 0. Again, I'm going to apply quadratic formula, negative b plus and minus b squared minus 4a into c and divided by 2a. At minimum, this formula you have to show to examiner. Some students write directly. This is not a right way. And when you plug in this one, so we get it here. We get here two answers. One answer I'm getting here 2 seconds, and one I'm getting here 7 seconds. I believe you got a point. It means it stops at 2 points. One is a 2 second, and one is a 7 second. Okay. So, but what is asking for? Find the distance we travel between these 2 points. So now, a very important 7 mark question, and I tell you very important thing which may affect the answer. So you have to be careful, especially when particle stops in the middle, and maybe there are two possibilities. We have to sketch this diagram, though he's not asking, but why sketching is important, you will come to know, because basic criteria is what? When the particle is traveling like this, going away positive speed, going back, coming back to observer negative, and this distance is always coming positive and this distance coming negative. And if you don't care about this negative sign, it will affect your answer. So now we'll check it here carefully. What is the situation of this diagram, this equation? So between 2 to 7, we have to check it carefully. And what is matter to check, students? So this velocity expression, I will check it, I will take it, and I will plug in some numbers and check the values becomes what. Okay. So what is the method to check? Okay. Now I will check some values. Especially this is a 1, this is a 2, this is a 3, this is a 4, this is a 5, this is 6, and this is 7. And here I take I take a time, and this is velocity I will make. That is why I have taken this equation. Okay. Now, students, what to do afterwards when I plug in these some numbers, okay, then what I get it. For example, when I plug in this 2 in the place of this equation, I am taking my own calculator, and let me check it finally. Equation is 0.3 t x square, I mean x square, same thing, 2.7 x and plus 4.2. Okay. You can use a table function available in your calculator as well, students. Okay. And what is star equation? Start from where? Start from 2, ends where? Ends at 7. Step, how much? You can take 0.5 step, or you can take 1 step. So when I check it, my answers are what? Let me show you the diagram. So against 1, I'm getting 0. Against 2, sorry. Against 2, I'm getting 0. Against 2.5 or against 3, I get negative 1.2. Okay, then I got against 4, negative 1.8. And then I got negative 1.875. Then I got against, negative 1.8. And then it is a turning back. I think 4.5 is the highest, and then 5 is turning back. This is a turning back. It means 4.5 we have the least, and then it becomes 0. It becomes 0 at 7. At 6 we have some. So actually, if we check it, the graph, students, the graph is parabolic curve like this. Like this. How come? You can see the power 2 and positive power 2. Whenever we have a plus t square, we have this kind of graph. A negative t square, we have this kind of graph. Make sure. Okay, that is why I have this. So thing is that is the negative, so it means the distance will come negative for sure. Why? Because below x-axis. So I'm going to do what? So I'm doing integrating the velocity, and you know it very well. If a velocity need a displacement, integration once again. So I'm going to integrate this equation. So let's see what happens. So I'm writing here distance is equal to 2 to 7, 0.3 increase, and 2.7 this, and 4.2 is not a problem, because luckily all distance is below x. Sometimes some above and some below. That is a difficult part, but inshallah, I hope so you understood. Increase the power by 1. I got 3 by 3. Increase the power by 1, 2 by 2, and 4 to this is and limit is a 2 to 7. So students, so when I plug in the answers, okay, and so let's see what happens. I get upper limit minus lower limit, distance traveled, okay. So 0.1 in a bracket 7 to power 3, negative 2.7 divided by 2 into 7 to power 2, and plus 4.2 into 7. When upper limit, I got it 49 over 20. Upper limit done, minus. And when I plug in the lower limit, students, so what happens? I'm plugging the 2 lower limit. Okay, lower limit, let me check what I get it finally. I'm getting 19 over 5. And when I do these subtraction, students, so negative 49 divided by 20 and negative 19 over 5, I'm getting here student distance turned to be negative 6.25. And negative will ignore and distance turned to 6.25, while logic is very clear below x-axis. And that is why we got a negative. Okay, so I hope so the point is very clear. Or you can put in the beginning here negative sign, just keeping the mention that because the curve below x-axis, that is by keeping negative sign to eliminate the negative and convert it to positive. And I hope so the concept is very clear and the paper is completely over. And best of luck for your coming exam. And I request you one thing: those questions which you had done mistake or you misunderstood after watching this video, reattempt. There's the only way to improvement is reattempt. And another key point: every question you make a diagram. You see, I never do the question without diagram. So diagram making and data writing is very, very important for the whole mechanics paper. I hope so. This is enough for today. Assalamu alaikum wa rahmatullahi.